This is Sargent, and this is a review of naming compounds and writing chemical formulas. We are about to enter our chemical reactions unit, so this is a good review to help us prepare for writing our chemical reactions, but can be used at any time to review naming compounds and writing chemical formulas. So to start off with, naming compounds. The rules for naming compounds of binary ionic compounds. Binary means that there are two elements in your chemical formula. So the first thing that we want to do is we want to name the metal cation first, and cations are positively charged. And then we want to name the non-metal anion second, and anion's a negative ion, so they're negatively charged. And we want to change the ending on our nonmetal to "-ide". So remember that metals are on the left side of your stair step on your periodic table and nonmetals are in the top right. When we look at our chemical formula, the first element is going to be your cation. So this first element is going to be your metal in binary ionic compounds. So we're going to name that. That is aluminum. Al is aluminum. And then Br is our nonmetal, bromine, but we're going to change the ending to "-ide, so this is aluminum bromide. Then our next one is Ba3N2. Our metal is Ba, which is barium. And N is nitrogen, but change the ending to "-ide, we get nitride. Naming binary ionic compounds with transition metals, the first thing that we want to do is we want to determine the charge on our ions. After we have the charges on our ions, then we're going to name the metal cation. Write the charge for the cation as a Roman numeral in parentheses, and then name the nonmetal anion with an "-ide ending. So if we look at these two chemical formulas, HgSe, so we want to first determine the charge on our ions. The thing with transition metals is that they can have multiple positive charges. So mercury, our transition metal, we don't know what its charge is. So you always want to look at the second part of your formula at the non-metal first. So selenium is in the 6a column, which means it needs to gain 2 electrons, giving it a 2- charge. If we have one mercury atom and one selenium atom, then mercury also needs to have a 2 charge, but a 2 positive to balance this out and equal 0. So our metal is mercury. The charge on mercury is 2, so we're putting 2 as a Roman numeral in parentheses. And then selenium, change the ending to "-ide, is going to go to selenide. Fe2O3. When you have two subscripts in your chemical formula, you can do the reverse crisscross. So this 2, take it up, and then check on your periodic table. Is oxygen a 2-? If so, you can continue working backwards, which oxygen is a 2-. So that means that iron is going to be a 3+. So we're going to name this iron 3 oxide. The rules for naming ionic compounds with polyatomic ions. Poly means that you have multiple, and so in a ionic compound with polyatomic ions, you're going to have more than 2 elements. The first thing that we want to do is we want to name the cation first, and our cation, remember, is positively charged. This is going to typically be a metal unless you have NH4 1+, which is ammonium, our only positively charged polyatomic ion. Then we are going to name the anion second, and our anion is negatively charged. If it is a polyatomic, you just take the name straight from your polyatomic list. If it is a single nonmetal, you're still going to change the ending to "-ide". So like I said, if you have more than 2 elements in your chemical formula, that is an indicator that you have a polyatomic ion. So we have 3 capital letters in this chemical formula, which means we have 3 different elements. So our cation is always going to be at the beginning. Na is sodium, so we're going to name that. And then this last part, these last 2 letters, is our polyatomic ion. That it comes from our polyatomic list, and the name of that is nitrate. Remember, on the back of your periodic table, you have a list of commonly used polyatomic ions with their formula and name for your reference. K2CO3. K is our cation, which is potassium. And then CO3 is our polyatomic ion, which is carbonate. NgOH2. So whenever you have parentheses in your chemical formula and a number on the outside, that means that you have more than one of your polyatomic ions. So Mg is our metal, which is magnesium. And then OH is hydroxide. Now we don't have to do anything in our name to indicate that there are 2 hydroxide ions, because magnesium is always going to be a 2+, hydroxide is always going to be a 1-. So if you have the name magnesium hydroxide, you can determine this chemical formula. NH4Cl. So our first part is our cation. Well, N is not a metal and it's not a cation, but NH4 is our positively charged polyatomic ion, which is ammonium. And then Cl is our anion. It's a single nonmetal, so it's going to go to chloride. So that's naming all of our ionic compounds. Our last type of compound that we name is our covalent compounds. With covalent compounds, you're going to have 2 nonmetals, or a nonmetal and a metalloid. The first thing that you want to do is you want to name the first nonmetal and add a prefix, except we never use the prefix mono on our first elements. And then we want to name the second nonmetal, drop the ending, add "-ide", as well as add a prefix. Remember, to the right of your polyatomic list on the back of your periodic table, you have a prefix list, and be sure to double check it and make sure you know what the prefix is for the number. So CO2. C is carbon, and we have 1 of those. Well, the prefix for 1 is mono, which we don't use on our first element. So this is carbon. And then O is oxygen. I'm going to go to oxide. The prefix for 2 is di, so this is carbon dioxide. And then P2O5. So we said that the prefix for 2 is di. P is phosphorus, so diphosphorus. And then 5 is penta, and O is oxygen, so this is going to go to pentoxide for the name, diphosphorus pentoxide. So that is a review of naming our compounds. Next, on the back side of your review sheet, you have writing compound formulas. And this is going to be the most useful part of the review for are writing chemical reactions because most of the time you're going to be given the name and have to write the chemical formula. Sometimes you will need to go from the chemical formula back to the name, what we just reviewed, but this is going to be what you do most often. If you cannot write your compound formula correctly, you're going to have a really hard time when it comes to balancing your chemical reaction, which is why we took the time to go over this review. So the rules for writing formulas for binary ionic compounds. The first thing that we want to do is write each element symbol. Magnesium is Mg, nitrogen is N. Then we want to determine the charge for each element. So make sure on your periodic table that you have your charges written in above your columns 1A through 7A. If you don't have that, be sure to ask me, ask a friend, and get it written in so you don't have to guess. Magnesium is in the 2A column, which means it's going to have a 2 plus charge. And nitrogen is in the 5A column, which means it's going to have a 3 minus charge. Then we want to balance out the charges using the crisscross method. When we do this, we take the number only and cross it over for the subscript of the other elements. And then we're going to rewrite our formula, dropping the charge signs and writing our numbers down low for subscripts. So we get Mg, this 3 comes over for the subscript, and then N, this 2 comes over for the subscript. So our formula is Mg3N2. There's not a common multiple between 3 and 2 besides 1, so this is our final formula. Make sure that you're writing your chemical formulas with your numbers down low as subscripts. I should not be seeing Mg3 and 2 with your numbers written up high. That is incorrect. If you think about it, subscript, so the beginning part of that word is sub. A submarine goes down low in the ocean. Well, subscripts go down low in your chemical formula. So make sure that you're writing those correctly so that they are recognizable as chemical formulas. If we want to try writing the formula for iron chloride, well, we know that iron is Fe and Cl is for chloride, but we don't know the charge on iron. We know that chlorine is a 1 minus. So in order to write this formula, we need to know what the charge is on iron. So the problem with writing formulas for compounds with transition metals is that transition metals can form more than one positive ion. So we need to know what is the charge on that positive ion. Iron has 2 possible charges, 2 plus and 3 plus. So we need to know, is this iron 2 chloride or is it iron 3 chloride? In order to determine the charge of a transition metals cation, we use Roman numerals. So here, this just kind of shows using Roman numerals in the names. Copper 1 chloride. This means that copper is a 1 plus. And so it needs 1 chlorine to balance it out, giving it the formula CuCl. Where copper 2 chloride is a 2 plus, so we need 2 chlorine atoms to balance it out. And this gives us the formula CuCl2. Copper 1 sulfide. Copper is a 1 plus, but sulfur is a 2 minus. So we're going to need 2 copper atoms to balance out that 1 sulfur. So we get Cu2S. And then copper 2 sulfide, we just need 1 sulfur to balance that out, giving us the formula Cus. So the charge on your transition metal is going to make a difference not only in the name in the Roman numerals, but it also makes a name in your chemical formula. So we need to know that in order to be able to write our chemical formula. The rules for writing formulas for ionic compounds with polyatomic ions. The first thing that you want to do is you want to write each element symbol or the formula for your polyatomic ion. So cesium is Cs and sulfate is SO4. Then we want to determine the charge for our element or our polyatomic ion. Cesium is in the 1A column, so it has a 1 plus charge. Sulfate has a 2 minus charge. So now we're going to use the same method of crisscrossing and take the number only, crisscross over for writing our chemical formula and balancing our charges. We get CS, the 2 comes down low for the subscript, and then SO4, and we only have one of those. So our chemical formula is CS2SO4. This is not a chemical formula that you can reduce down. SO4 is the formula for sulfate, and that's never going to change. We would need to have parentheses around this and a number on the outside of the parentheses in order to reduce this. So this is as simplified as it can be. Magnesium phosphate. So Mg has a 2 plus, and then phosphate is PO4 3 minus. So we take the numbers and crisscross over to balance out our charges, and then rewrite your formula. Mg, this 3 comes down low for the subscript, and PO4, we have 2 of those. So that means that we need to put our PO4 in parentheses and the 2 on the outside. So our chemical formula for magnesium phosphate is Mg3PO42. And 3 and 2 can't be reduced down any further, so we have our chemical formula there. So that is a review of writing our formulas for ionic compounds. Our last type of compound is our covalent compounds. And in order to do this, we want to write each element symbol and then turn the prefix for each element into a number and write it as a subscript. So disulfur trioxide. Sulfur is an S, oxide is oxygen, and it's an O. The prefix di is 2, and the prefix tri is 3. So our formula is S2O3. And then for phosphorus pentachloride, we have P for phosphorus, and only one of those. And then chloride is Cl, and the prefix penta is 5, so this is PCl5. So that concludes our review of naming compounds and writing chemical formulas. If you are having trouble with this, please stop by and see me to get help. We have a review of naming compounds that was given to you in class, and this will help you with that. If you need more help, please come and see me sooner than later so that I can help you with this. Thanks. Have a great day.